Good evening. So we'll start the session at 6:10 if others are joining. Till then, if you have any questions regarding the last assignments or anything, you can ask. Uh, Jayanti is there, yeah. You asked about the integer metrics, right? Last time.
Yes, sir.
Yeah, so we can use rand int. Okay, I'll just show that during session only. Okay, fine.
Okay, sir.
Hmm.
Sir,
Yes, yes.
I tried particle swarm through
Hmm.
MATLAB.
Hmm.
It's not giving answer. Nothing, no reaction. Other methods, when I have checked with some matrix answer has come. Last week I got the answers, but this week I don't know MATLAB any problem.
Oh, oh, oh. You are using the online version only.
Yes, sir. Online version.
Can you just show me now if it's possible?
Yes, sir. Possible, sir.
Yeah, yeah,
Possible.
please.
It's opening.
Hmm.
How do I share the screen, sir?
You can just share the screen. Share screen option will be there.
Even participants can
Yes, yes,
can
yes.
share.
Hmm.
Something else is coming.
Yeah.
I will share another screen. I shared the wrong screen.
Oh, okay, okay. It's fine.
Is MATLAB coding visible, sir?
Hmm.
I am running this. Okay. Now its error is coming. Morning.
Yeah, I think that error
Mhm.
is because of that. In the fourth line, no, x
Fourth
and then
line.
the
Yes.
x1 x2 here you have written that should be in third bracket.
Yes.
It seems x and then 1 should be in third bracket, like square
Okay. Okay.
brackets. Try once. Change all those. Now try once. Okay, wait. When calling a function,
Line.
parenthesis. In that bracket is not, and I think there is some issue there. Wait, let me check. Okay, this equation anyway we'll do in today's session. It's fine, we'll do it. You'll see.
Okay, sir.
Hmm.
Okay, sir. We will see.
Yeah, we'll see, we'll see. Okay, we'll start the session at 6:10 only. If others are joining, otherwise we'll start the session at 6:10.
Okay, sir.
Yes. Okay, I think that is for okay, wait. Yeah, in MATLAB you can use first bracket only. Okay, that third bracket was for R. Okay, so I think first bracket will should work. Okay, anyway, we'll do that today.
Now nothing is coming. No error or answer. Nothing is coming, sir.
Okay,
The answer is also not coming. Message error, message warning. Nothing is coming.
okay, okay. We'll see. We'll see. It's fine. Let me see.
Should we mention display option, display command? Nothing. It will come.
Try once if it is. It should
Display
work like that
F1.
only if you are not
Ah,
using
yes.
that.
Online version only, sir. I registered and I used.
It should work. Okay, so we'll start the session. Hello everyone. So today we are going to discuss about the tutorial session for the last lecture. So that is the week 12 lectures. So till now what all we have studied? We have studied all the like whatever was in the syllabus, all the optimization methods, maybe classical optimization if you say, which uses the gradient to understand which way to go. Then we have seen the meta heuristic optimization. In that we have seen genetic algorithm, then particle swarm optimization, differential evolution, and so on, right? So what we have to do, the main focus of ours, it should not be like just doing the assignment questions, getting numbers and exams and then numbers. It should, you should learn whatever subject we are studying, right? So we should know that what is the physics behind it, what is the process that is involved. So what is whatever we are studying, you should understand that first. Chetan, you have any question? Mr. Chetan? I think it was big. Okay, fine. So yeah, what I was saying. Hmm. So we have to understand whatever. Okay, okay, okay. So whatever we have studied till now, we should understand what is the main physics behind it, right? And then we should also be able to solve those manually. So we need to understand the physics or the process behind it. we need to do it mathematically, analytically by hand. And then after all this, when we know that what is the physics behind it and what is the mathematics behind it, then what we have to do, we have to code it, right? So we should be able to do all these three things from this course. So anyway, we have seen the optimization in our software, the classical optimization. Then we have seen that in MATLAB also. And in this week lectures, the week 12 lecture is fully focused on the optimization using softwares. So what softwares we are using? We are using R. We'll be seeing in MATLAB. We have seen all those, and some of the processes which are left, we'll be finishing that. And then we'll also see that how we can do optimization using Excel solver. Okay. Other than this, you can do it in Python, you can do it in any other programming languages. Okay, it's not restricted that you have to do in R or you have to do in MATLAB. So why we used R and MATLAB? Because in R and MATLAB, direct functions were there. In Python also direct functions are there, you can use those. So like that, we are using these softwares for that. Okay, so let's start. I'll share the presentation first. I'll switch off this so that, okay. Okay, I hope you can see my screen. Okay, so hello everyone. I'm Balram Shah. I'm the PMRF TA for this course, that is Optimization Methods for Civil Engineering, and I'm doing my PhD at Interdisciplinary Center for Water Research at ISC Bangalore. So today we will be discussing about the week 12 lectures of this course. So let's start with some assignment question. So first assignment question is this, that is, consider the function fx is equals to 3x to the power 4 plus 24x square minus 9, and we will use Excel to find the value of x that minimize the function f if selected method in Excel is GRG nonlinear. Again, this GRG nonlinear as in generalized reduced gradient. So here what we are using gradient information, but for nonlinear functions in Excel to optimize the function. Optimize as in here they are asking to minimize the function. So we'll minimize the function, and from that the question is which of the following is correct. Okay, so function is 3x power 4 plus 24x square. I'll write that, else I have to see again and again. 3x power 4 plus 2x power square minus 9. Okay, okay, so we'll see that in Excel. I'll open Excel here. So for this solving, for doing any optimization in Excel, we need solver. Okay, so if you go to data, okay, here I have not installed the solver yet, so I'll show how to install solver add-in, and then we'll go to how to do that. So just go to the file. If you go to options, yeah, here you can find add-ins. Just click on add-ins, and then in manage Excel add-ins, click on go. Then here you can see solver add-in. You just tick it, and then okay. Now your solver add-in will be installed in Excel. So now here you can see in the data section, you can see at the end, you will see in analyze, you can see the solver option. Okay, so we'll just write all the things. So we have this, the question was for a single variable, right? So we'll write variable was what, x. Okay, and we have objective function. Let's say I'll write objective function, and objective function, let's say I'm writing it as f. Okay, now in the any of these methods, what we have to do, we have to initialize or give an initial value for the variable. Okay, so let's say we will keep initial variable as 0. What was the function? The function was 3x to the power 4 plus 2x square minus 9. Okay, so we'll write that only, equals to 3 into x is what here, x is the variable, so the value is 0, so we'll just put this x to the power 4. Okay, then plus 2x square, so plus 2 into, again x is what, x is this value, so just click on this, x is square minus 9, right? This was the function, just click enter. Now for initial value of 0 it is minus 9. What we have to do, we have to minimize this function. So this is what, this is a unconstrained problem, so we don't have any constraint. Also this is a single variable problem, so this is the simple one that we used to do in the beginning, but this is a non-linear function, right? Okay, so we'll do that. So just go to this solver option. Here you have to see what is this, this is set objective, so we have to set the objective. So which one is our objective? Our objective function is this value, right? So here we have written the formula, so just click on this. So here you can see C4, okay, and this dollar symbol represents that it will not change if you change. I'll just go down and so on. What we have to do, we have to minimize the function. In the question you have, must have seen that we have to minimize, so will click on minimize. Now which variables can change? Here the variables that can change at each iteration will be this, that is x, right? We'll just click, oh sorry, I have not clicked on this, so just click on this. Okay, and as it was an unconstrained problem, we don't need to put any constraints here. Okay, so we'll not do anything here. Here what is there, it's saying make unconstrained variables non-negative. Okay, so here make unconstrained variables non-negative, as in if we are not giving any constraint, or let's say whatever constraints are there, so this means that any variables is having, is if we switch it on or take it, then what will happen, then whatever values or whatever variables here we have, it will not take any non-negative values. You can just untick here because it was not given, I think, in the question. Here again you see there are select a solving method, so there are few methods that you can see here: grg nonlinear, then simplex, lp, evolutionary, and all. So first of all, as it was mentioned, we'll take grg nonlinear and then we'll solve. See here you can see the option keep solver solution or restore original value, so we'll just keep solver solution. If you click OK, okay, so 0 was the, okay, this one was the correct value only, so we'll just select some other initial value, maybe give me a number, any number, any initial value. If you say
2.
2, okay, see we have clicked 2, now it's 47. If you just put x in this function, you'll get 47. Now you will use solver function. Okay, so again objective is the same, C4, right? And then changing value will be, changing cell will be this variable should change, right? Everything will be same. We'll just solve this and we'll click OK. So here you can see with initial value 2, what we are getting, we are getting value of minus 0.00000 till 9th power 5. So the value is approximately 0 and the function value will be 9. Now again we'll just see with another value, maybe 1. And here if you see, okay, wait, here if you see it is taking one negative value, right? Again, if let's say if we are giving 2 only, okay, and in solver option, if you just switch it on, this make unconstrained variables non-negative, so whatever variables we are considering it cannot take any negative value. Okay, and if we solve now, see you can see the variable is 0. In the last case also, when we are considering that the values can take a negative value, in that case what was happening, that it was getting to 0, but it was like at 9th power, right, 10 to the power minus 9, so it was a very small value. So that also we can consider. So but the answer is 0, okay, and the function value is minus 9. Okay, I hope this is clear. We'll go to that question and we'll see what are the options. So the correct answer is this: x equals to 0 and f equals to minus 9. Okay, I hope this is clear. Then the next question is, if you used simplex linear programming in Excel for the above problem, the following warning message will be displayed. What is the message? That the linearity conditions required by this LP solver are not satisfied. So options are yes or no. We'll see that. So same problem we have to see, but we'll use So let's say we are keeping 2 only here. Okay, wait. Okay, so what I was saying, yeah. So if okay, we'll go to solver option again. Now here you see, if I am changing this grg non-linear to simplex lp, okay, and we are trying to solve, see what is it is saying. It is saying the linearity conditions required by this lp solvers are not satisfied. So the correct answer for that will be yes. But my question is, why it is saying this? Why it is not solving this objective function or this optimization problem? Can anyone give me answer?
Sir, could you go back to that question slide?
Question slide.
Meaning-
Okay.
Okay,
No, no,
because
no.
of
Yeah, that question is fine. That the question was whether this it will show this message or not. What was the message? I'll show it again.
linearity conditions required
Yes.
by the LP
So
solver.
it is saying that the linearity condition required by this LP solver are not satisfied. So the correct answer for that question
Because
is yes.
it's not linear, it is
Correct.
x power 4.
Yeah, correct. Because if you see this equation here, here it is 3x to the power 4 plus 2x square. So this is not a linear programming problem. So this simplex is made for only the linear programming problem. If the objective function or if the constraints whatever are there, if those are linear, then only we can use the simplex programming problem method, right? So that's why it was showing like that. So we'll go to that, not this. Yeah. Yeah, so the correct answer is yes for this. Okay, so Excel is fine. We'll move to the next, particle swarm optimization. I'm not explaining all the particle swarm optimization methods and all, because I have explained all this in the last tutorial sessions and all, right? So today whatever we will see, we'll only see the codes, we'll see the softwares and how it works and so on. Okay, so here what is the question? Find the optimum of the following function using particle swarm optimization method. For swarm size is given as 100. Generate the MATLAB code to solve this. So this is the same question you are referring, I guess, right? Uh,
Yes, sir.
the constraints are x values linear, lower bound is -3, and also y is lower bound is -3, upper bound is 3. These are the options. Okay, so we'll just go to MATLAB. Mm. Okay, before that we'll just a quick revision we'll do, that what how we have seen the particle swarm optimization. I'll clear all this first. Yeah, so if you run just from here, the whole script will be run. Just click F9 and whatever you have selected will be run. Okay, we'll just close all this. Okay, yeah. So let's say if you have any unconstrained single variable problem, sorry, optimization problem, then how we can solve? You can first, we have to create that function. Either you can create the function in the script itself, or you can create that function in some other MATLAB file also, or .m file. Okay, and then just call that function when you are doing this particle swarm optimization. So in this methods, that is the meta heuristic optimization methods, such as evolutionary, not the whole meta heuristic optimization, but the evolutionary algorithm whatever are there, just for example particle swarm optimization or GA, what we need the lower bound and upper bound. Okay, so let's say we are defining the lower bound of x at 0 and upper bound at 8. Okay, and you can give some options also, that the optimization options are particle swarm. So you can, if you don't know that what is this particle swarm is there, like how it works, how you can write the arguments, the syntax, you can just write help and particle, sorry, swarm. Okay, did I write anything wrong or what? Okay, We'll see, it should work.
Or else we can search in the documentation.
Yeah, directly we can search in the documentation. What is that? Okay, we'll go to that later, or else you can directly search here also. I was expecting it should also work. Okay, so there are several options. You can just see in which particle swarm optimization is there and just check that. Okay, we'll not go into that because we have done all this in the last class, I guess. Okay, so the options are optimization options will be particle swarm optimization will use method. The swarm size we have not mentioned here, I guess. Okay, so here if you just, okay, this will go, swarm size we have mentioned. Swarm size is how much? 20. Okay, and then we'll define the particle swarm function and get the output. So this x is what? X is the variable at what x the function will be optimized. Okay, and f val means the function value. This means at this x, or at what x value we have the optimized function value, that value is f val. Now we'll use the particle swarm and then objective function. This objective function, this name should be properly written. Whatever function you have given here, the name, you should write it here. Okay, and then all these things. Okay, we'll just see if it works. F9. Okay, invalid solver specified. Wait a minute, we got something. Invalid solver specified, but gave me answer. No, it didn't. Okay, where is the issue? Let me see. And it is taking this also, it took. Oh, here only the options. Let me see what is the issue. First I'll open all those first. Wait. Some issue here. This was optim options only, I hope that. Where is the documentation part? कहाँ गया? Particles on some size. Fine. This is correct only. Algorithm, objective function, options 1, L and B.
Sir,
Yeah, yeah.
you got objective function comma 1. Maybe that is the reason. Comma.
Here.
Particle swarm. Why this one, sir?
16th line you are
You,
saying?
Yes, sir.
Okay. Let me see. No, the option. Yeah, the problem is here only, I guess. Let me see once. Yeah, that one was for something. I'll see. Wait. One I wrote for something. Algorithm. Okay, we'll get back to this later. First,
Here
let.
also objective function command 2.
Yeah, that
What
is.
is the, why should we need that one, sir?
Yeah, let me check. Where you have saw that too?
In question, assignment question.
Oh, assignment question. Yeah, it should be that particle swarm only. I should get first. There it
Okay,
is
sir.
mentioned
Sorry,
properly.
sir.
Give me a minute. Mm, here somewhere. Particles. Yeah. Okay. Lower bound, upper bound we give. Particle swarm function. Yeah, that is the number of variables. That one is the number of variables here. So here we have only one variable, right? X. That's why it is one.
Yes, sir.
For
Yes.
your case,
Okay,
whatever you are saying two, it should be having two variables.
okay, sir.
Okay. First, let me check why it's not working. Uh, Optim options is only not working properly. Particle swarm XFL. Hmm. XFL. Okay, I'll write the whole thing first. Exit flag. Value assigned here to X is to be unused. Then F value is also unused. Hmm. Okay, we'll see the other first. Wait. Globe Ocha toolbox is not there. Wait. Yeah, so this toolbox should be there, okay? This global optimization toolbox. Because of this, it is not taking. Okay, I'll just
So how do we ensure that one? Whether toolbox is
see here.
available?
Here you can see that particle swarm requires global optimization toolbox. So for
Okay,
that
sir.
we need the toolbox because in this only that function is written and hence we have to use that. Uh, I did it in another system and that's why this have to install all this again. Okay. No, I will not remember the password also. password I don't remember. Give me a minute, let me see. Let's see if this works. uh, didn't get the mail yet. Oh, okay, sorry. भाई प्लीज हो जा. Can you guys see the other screen that I'm showing?
Yes, sir.
Uh,
That folder.
one MATLAB file I have opened.
Yes, sir. Yes,
Okay,
sir. Visible, sir.
okay, okay. Let me see if here it works. Yeah, so right now there is some issue with my password in MATLAB and all. So I'm showing from here only. So in this system only I worked, and because of that. So sorry for the inconvenience. Okay, so you have to install that what was that global optimization toolbox. Okay, for that you need this, what to say, sign in and all. Okay, okay. So here you can see. Can you see the screen properly, or should I increase the font? I hope
Yes, sir. Now
now
it's
it's fine, right? Okay.
yes.
Yeah, so this is the same whatever I was showing. This is the function, that is 2x cube minus 3x square minus 12x x plus 4. Okay, and the lower bound and upper bound we have given as 0 and 8. We are just using this. If you just press F9, see, you are getting x as 1.9999 something. So the correct answer will be 2, and the val is minus 16. Okay, so this one was for single variable unconstrained optimization. Okay, so these all we have seen last class only. Now we will move to the constrained multivariable function. So we have multivariable function as the objective function, and we have few constraints to it. Okay, so we'll see that. So see, again we are putting some lower bound and upper bound to it, right? So lower bound is given as x1 and x2 should be greater than equals to 0. So lower bound is how much? 0. And x2 and x1 should be less than equals to 5, and hence the upper bound is 5. Okay, so the lower bound, so this zeros 1 2 means what? Can anyone just tell me?
One row, two column.
Yes, one row, two column with elements as zeros. Okay.
Zero.
And next is upper bound. Upper bound is 5 into ones of 1 comma 2. This means, so this means what? This means it will create
One comma
1 comma 1 and 1.
column matrix.
uh,
One one.
1 1, sorry, row 1, one row and two columns will be there, right? So 1 1 into
Yes,
5,
sir.
so 5 5 it will be. Okay, now fitness function is of1. So here directly you can write the function, or you can just write in some other MATLAB file. Okay, so this is the function that I have written. So function f equals to of1 x, where x is a variable. Now, as we have seen in the last classes also, that how we can write, if this x here we are writing and we are putting x1 x2, then this is what? This is a vector having two variables, that is x1 and x2, right? So of we are just putting, so this is the function, this is the function. Okay, so the function is x1 square plus x2 minus 11 whole square, and plus x1 plus x2 square minus 7 square. Okay, and there are two constants to it. First constraint is minus 26 x1 minus 5 whole square plus x2 to the power 13. Okay, I think this is one of the problem today. Okay, fine. So this is the function
X
that we
to
can,
power 13, sir.
yeah, x to the power 13. Okay, so this is the
Oh, power 13.
it's
Okay.
fine, it's possible. Constant can be anything. Okay, now
Okay, sir.
so the other constraint is minus 20 plus 4 x1 x2. Okay, now what is the constraint? Constraint is this constraint should be less than equals to type. So what we are using, we are using if else condition. So if the first constraint is less than equals to 0 and the second constraint is less than 0, then function is this function. Or else what we are doing, we are adding one offset to it. Okay, so we are just adding one offset, that is 10 to the power 5. Okay, so that it can become a very large value. Now let's move and let's do this. So this function you can write in this script also, at the end you can write, or else you can write directly here also. So whatever is fine for you. Okay, F9. See, you can see now. So this res is what? Res is the result of the or the x1 x2 value, f-val is the optimized function value. So the results are what, 3.18176a something something and 1.27136 something something. So these are x1 and x2 and the function value is 5. Okay, so here what you can see, particle swarm we can use several things. So this is the particle swarm optimization function. Okay, this is needed, and for this we need to install that global optimization toolbox. Okay, you can just go on add-ons, and here you can get add-ons, and then you can just install that. Then this is the fitness function. Okay, so here we are writing fitness function, in which in fitness function what is there, this o1 function is there, which we have created in another file as this one. Okay, this creating and all we have seen before, so I'm not explaining that. Then 2, this 2 is what, this 2 is the number of, sorry, this 2 is the number of variables that you have in the functions, maybe objective function, constraint, whatever. So 2 is x1 x2, lb is lower bound that we have just initiated or written, and ub is the upper bound. Other than that we can write options also, that which kind of, like what all, how many iterations you want, and so on. Okay, that also we'll see. So with this we'll move to the mm,
Sir,
question. Yes, yes.
in say graded assignment, they asked simply optimize the blank is given. We have to write the function value, name function value, isn't it, sir?
What is the question in there?
Seventh question: optimize the
Hmm.
function using genetic algorithm. Functions are given, constraint is given.
Hmm.
Blank spaces there. We have to fill that in that blank space.
Is there any hint in there?
Hint.
Below that, if
Okay.
hint is there,
Write the answer in the form.
so that form you have to write.
Okay, sir.
Okay. Hmm. Okay, so we'll move to the questions. So this, till this it is clear, right? Particle sum optimization you for multivariable
Yes.
and single variable, right?
Yes, sir.
Okay,
Very
so we'll
good.
move to the questions. You can see the presentation slide, right?
Yes, sir.
Okay. Okay, so this is the question. If your MATLAB is open, you guys can just try once. So here what we have to put, so let's say at x you can put x1, y x2, but the lower bound for x1 and x2 will be -3, and the upper bound will be 3.
Yes,
Okay,
three.
and just put this. Do you want me to open
We
that
have,
MATLAB file, or this file and this screen is fine?
the screen is fine, sir.
Okay.
I have done it,
Uh-huh.
but I couldn't, the values are not displaying. I have taken from the workspace matrix, X value, F workspace.
Oh, okay. So answer is coming, you are saying, but not in
Yes, sir.
the command prompt, or
Command window, it is
command
not
window.
coming,
Okay,
but
okay.
in from the workspace.
Okay, it should come. Uh,
Don't know what
okay,
is the
can you
problem. I
show
will.
me once more? Wait.
Okay, sir.
Yeah, wait a minute. I'll stop sharing. Okay, it's 7. I have to finish also. Yeah, remove that. Go. Remove that
That
semicolon.
colon.
Yes, and try once. Still not showing.
Yes, sir. So I have taken from here.
That is fine. Okay, fine. Okay, I'll see that. It should.
These are
This
the
is also
values.
fine. So we should take from there only. But here
Yes.
also it should come. Okay. Okay. Fine.
Okay.
Fine.
F
If
value
I
I have
see
taken from.
something, I'll inform you later. Okay.
Yes. Okay, sir.
Okay. Yeah, that's- Yeah, you all can just try this.
Answer is 8, 3, 2.
Yeah, yeah, so we'll see also. Let me see in MATLAB. Yeah, so that I have written somewhere. This one, right? Yeah, so this one is the code for that. Okay, so you can write the function directly here also, so I have written like that. Okay, the lower bound is -3, as because we have two variables, so two columns, one row for x1 and x2, multiplied by -3, it is -3 and -3. Okay, so it is mentioned that 100 number of swarm size or population size we have to take, that's why we are putting 100 here. Okay, or else if you don't put, whatever default value will be there in this optimum options for particle swarm, it will take that only. Okay, I'll just here OF is what? OF is this function, right? 2 is the number of variables, LB is the lower bound and all these now we know. So these options only I was talking about previously. So we can give number of swarm, like what is the swarm size and all we can give. So whatever you can go into the particle swarm. So if I, as I was saying that now, particle swarm, see here you can see the whole documentation if you click on this, or else you can just see here also. Same thing, whatever you can see it here, you can see properly in that. Yes. Yeah, see here we can write x as particle swarm fun. Fun is the function. N vars means number of variables. LB is the lower bound. UB is the upper bound, and options. Again, for these options, oh, you can see the optim options. Okay, what are the optim options? Like that, you can just write help optim options, or you can directly go to the documentation and search optim options, and you can just look into that. Okay, so we'll just run this and we'll see. F9. Okay, so the correct answer is 3 comma 1.99, or let's say for one integer if you say 2, 3 comma 2, and the value is 0 maybe. Yeah, because it is e to the power minus 19, right? Okay, so we'll move to the next question. Oh, where did I come? Okay, using two systems at a time is difficult. Yeah, so the correct answer for this is 3 comma 2. Okay, next question is find the optimum of the following function using particle swarm optimization. Again, for swarm size 100, function is different. Can just do this, try once. All of you can try. If you are, if it is not possible for you for switching on the audio, you can just write in the text box, chat box. Okay, anyone is trying? If not, I'll just show it. I have written this anyway.
Trying, sir, last
Last.
sentence.
Yeah, okay, fine.
X values are 0, 0, minus 0. Option A.
Option A, let me see.
Yes.
Yeah, option A is the correct answer. I'll just do it once. Hmm. Yeah, so this is the problem, I think. Yes. So the function again. So see again, I am writing OF only. So if I don't run this line, this OF line, and just run from here to here, then in this OF, which function will come? This function will come. Okay. So that's why you can just change the name of the variable if you want. Okay, whatever. So anyway, we are running this variable again. So this means what? This function again will be loaded in this OF. Okay, so OF is the function. The function can be written like this: 100 plus 9x1 square minus 5 x1 sine x1 x2 plus 9x square x2 square plus x2. Okay, and lower bound as it was minus 6 or something, minus 6 to 3. Sorry, no, it was minus 6 and 6. Okay, so here I have to write 6. Sorry. Okay, and then particle swarm size 100 and so on. Okay, fine. We'll just run this. So how much we are getting? We are getting minus 0.0167 and minus 0.0601 whatever, and the f value is 100 and 99.969, so you can see it as 100. Okay, so we'll move to the next question. Okay, so again you have to use particle swarm optimization and generate the MATLAB code to solve. This is the last question for particle swarm optimization, I suppose. So now before this we didn't have any constraint other than the variable constraint, right? So we only have x1 and x2 is ranging from this to this. In last problem also we had, what is that, what happened? Yeah, in this also we have only the range for x and y, but now we can have constraints also, right? So let's say you have this function, you have to minimize x1 x2. The function is x1 x2 plus x2 plus 1. Okay, and it is subjected to constraints. Two constraints are there and one non-negativity constraint is there. Okay, you just need to do this and tell me the function value. Try once. I'll wait for 5 minutes maybe. So okay, before this I'll show you only, because maybe would not have seen. Okay, sorry. Yeah, so in this what we have now, we have more than one function. We have objective function. Other than that we have functions which are constrained. So how we can write that? I'll just show that. Okay, anyway I have shown that, I think, in O1, right? Here you can see when we have one objective function, you can write objective function and then you can write constraints. Whatever constraints are there, you can write those constraints, and then remember we have to keep it as negativity, less than equal to type or greater than equal to type, whatever is there we have to put that, right? So we'll use if else condition, and then if it is not satisfied we can give a proper offset. Okay, and based on that you can just write the functions. I hope it is clear. Just try once.
Sir,
Yes,
this
yes.
constraint minus x1, x2, that 100 should come on the left hand side. Minus
Yeah, you
100.
can write minus x1 x2 minus 100 is less than equals
Okay,
to
sir.
100. Yeah.
Okay. function value we need to do. Okay.
How much?
Function value.
F or whatever function you are giving, right, that you should get f val.
I am not getting that
Okay,
answer.
I'll show what. Okay, so I have written where. Okay, so this is the function that I have written. I think this is the function, right?
Yes.
Yeah, so it is x1 x2 plus x2 plus 1, and constants are 15 plus x1 x2 minus 20 x1 minus 30 x2. Second constant is minus 100 minus x1 x2, and if both are less than 0, in otherwise we are keeping one offset. Okay, now we'll see this where I have called this is ob function. Yeah, so you can just lower bound and upper bound are correct, right? 0 and 5. Can I
Yes,
check?
sir.
Yeah,
We
okay.
have given.
Okay, fitness function. I'm taking this ob function. Okay, and just do that. 9. Okay, there is some issue. Let me see. And then first what I have written. My val
It's
particles.
one function value.
No, we have to function value.
No.
Oh, answer is 1. Yes, yes.
Answer one.
Yeah, 1 only.
Okay, sir.
Yeah, let me see where I have done mistake. Seed mixed inverse. Acha, OB fun they are not getting. Okay, fine. Okay, wait. OB fun I have not opened, I think. Fitness function OB fun I'm keeping. Correct only. It should take. And remember, whenever you are calling any function, the function if you have created in any other MATLAB file, it should be in the same directory to run. Okay. Yeah. So we got the answer. The x1 x2 values are 4.67 and 0, and the function value is 1.
What is the x1, x2 value?
4.67 and 0.
1.374.
Okay, it can have because
X1,
it's I think
x1,
it
x2
can.
values are 1.3740, comma 0.
Mm,
Function value 1.
function value is 1. Fine. Let me check again. See, it's a particle
Okay.
swarm optimization
Particles.
we are taking. No, it can take some local optimum also.
Okay, sir.
This evolution algorithms, it mostly will give you near optimal answers. And if there are so many global, no, not global, local optimums, it will go near that. So because of in the last classes also you have seen one surface which are having four local big optimums minimum,
Yes,
and
sir. Yes, sir.
when you are doing the same thing using genetic algorithm, in sometimes you are getting in some other location and sometimes you are getting in some other location, so like that this x1 x2 value, that's why we have not put that x1 x2 in the answer. Okay. Okay, so we'll move to the next question. Particle swarm optimization done, I think. Okay, this is done. Answer is 1, B answer. Okay, next question is use differential evolution to minimize this function, that is 10 x2 minus x1 square whole square plus 1 minus x1 square, and it varies from minus 6 to 6. Initial value you want you need, so just take it as 0 comma 0. Okay, we'll just see. So this will do in R. Okay, so before that in the last class we have seen the differential equation, right? Sorry, differential evolution. Just add that here.
Using
Sorry.
MATLAB, sir. This
MATLAB
we
also you
can't
can
do.
do.
Okay, sir.
Uh, I have written that code in R only, so I'm just putting that here only. You can write in MATLAB or wherever you want. Why it's not opening?
Okay, sir.
Okay, fine. Control O. Mm, yeah, yeah. So as we know that we have to install this package, that is DE Optim. We have installed in this, so I'll just. So for that, you need this library. So to call that function, so library DE Optim. This all we have seen in the last class, but just a small recap that how we are writing the function again. Let's say if you are having two variables, you can write like this. If we are writing two variables here, this means we are considering that as scalar input. Okay, so here it is written in scalar input. Same again, x1 and x2 you are keeping some values initially, started from 0 to 5 with a difference of 0.1, and then using this x1 and x2 value to calculate this function value, that is f1, and hence outer will do what? Outer will calculate the function, that is f1 at x1 and x2 value, which we are keeping in another vector, that is z. This p what it will do, I'll just clear this and I'll just show them. Okay, and this okay, I'll just do this first. Control enter. Okay, so we have all this function, what is the function, x1 x2 values or the vectors with all the values, then z with all the values, and so on. Now this prsp, what it will do, just control enter. See, prsp, what it will do, it will show you the 3D plot. Now if you give the angles theta and alpha and all, and then it will show you on that angle. Okay, so these all things we have just seen. With this contour, what you will get the contour plot of the same figure. Okay, this is the contour plot. Now if you want to write this function but in the input should be in vector form, then how we will write? You just take x, and this x is a vector having two elements, that is x1 and x2. Okay, so this is the same function that we are writing but in the form of uh, vector input. Okay, now we want to optimize this function, and the result we are putting it here in the variable res. So we are using doptim. We'll just run that and we'll plot that also. Okay, control enter. See, now you can see the x1 value maybe at 3 and this at 1.2 something. So best member is x1 is 3 and x2 is 2. Okay, best value is in the function value is coming as 0 after 200 generation, and function is evaluated for 4020 times. Okay, now again you can give some more options in this, such as you can specify how many iterations you want. Okay, and these things, what is f and cr, you can just go to the help here and you can just find that topic here. Okay, this is for particle swarm and all whatever. So we'll do this also with the option. Let me just control enter. See, here also you are getting 3 and 2, but in 100 generations only we are getting. In the last, how much generation it was? 200 or 400 generation something it was here. It was 200 generation by default. Okay, so these things we have seen the last class only. So we'll move to our question. Now what we have constraint optimization, which we have to do using differential evolution method. Okay, so the question is same on what, let me check once. Okay, this should be, this also I should have written somewhere, let me check. Okay, first let's move on to the constraint optimization first. Okay, so the function is what? Function is x1 minus 2 whole square plus x2 minus 1 whole square. Okay, and x1 is less than equals to x2. Oh no, sorry, this is not less than equals to, this is equal sign. Okay, I have told you in the first tutorial of R only, right? So again same thing whatever we have seen. So just if you just want to plot this curve is what? Curve is c x2, and x2 is equals to 2 minus x. Okay, so this is one constraint. which will be plotted. So just to plot we are doing this. Okay, so for plotting curve we can use curve, for plotting contours we can plot contours. If you just plot this, so you'll get, okay, if you zoom this, okay, so this you can see, so this aspect ratio and all you can just give proper options here and you can correct it. Okay, so this blue lines whatever you can see is the surface or the function objective function. These two curves, that is green colored curves you can see, are the constraints. So if you don't give this constraint, you will get the optimized or the minimum value here somewhere, but with all these constraint you will get it here. Okay, okay, I'll move to the next part. So now again this can be written in the, so here what we have did, we did this in scalar form. Okay, now we will do the optimization. So here what we are doing, we are using the function again, but again here we are writing in the MATLAB also, we are writing like that, right? So we are say creating one function, in that we'll first specify the objective function and then all the constraints, right? So here also similar thing we'll do. So remember, when you are doing in R, third bracket will give you the element value, whereas in MATLAB it will be the first bracket. Okay, so f1 equals x1 minus 2 whole square plus x2 minus 1 whole square. The first constraint is x1 plus x2 minus 2, and the second constraint is x1 square minus x2. Okay, again we'll put one if else condition. So if you can put it as 10 to the power 5 also, whatever, some big offset you can just put. So this is the function that we have created. Okay, now we are using differential evolution optimization method to solve this function, that is x1 minus x2 whole square plus x2 minus 1 whole square. Okay, so we'll just do this, and this PCH2 size of the points, this COL equals 6 is in color of 6. So this, if you go to the help section or the documentation section, you'll see what this 6 represent and all. Okay, and anything other than that we have to explain. So this, in this you will get the result, okay, or the values, and then you want to plot that point on the same figure. Then result, what in result you want the optim value, and what in optim, the best member. Okay, so we'll just do this, control enter. So see, you got a point here. If I zoom you can understand that. So this is point. Okay, you can't see this because I have directly plotted this. So here you can see the best value is 1 and best member is also 1. Okay, both are 1 1 1, everything is 1 only. Or else you can just check result here. See, here you can see the result, right? See result optim, list of 4, we'll see this, what is this, best member is 1 comma 1, best value is 1. How many iterations has been done? 200 iterations. And how many function evaluation has been done? 4020 iteration. Okay, these are the lower bound, upper bound, whatever we have specified. Okay, I hope this is clear. If this is clear, we can go to the assignment questions. You can give me a thumbs up or something.
Yeah.
Clear, right? Okay.
Yes, sir.
Yeah, so you want to try it now in R, or just I'll show, because we have 2-3 more problems. I think it's 7:20. Anyone wants to try now, or else
We,
we'll move?
we will try later, sir, after the class.
Yeah. Okay. Okay. So the question was what? Let me just see which question it was. It is 10 x2 minus x1 square whole square plus 1 minus x1 square. Okay. So if you just see it here. Oh, sorry, not this. Okay. So we'll move to the problem. This is the problem, right? 10 x2 minus x1 square whole square plus 1 minus x1 whole square, right? So we have written that function. So here we don't have any constraints. We have seen the, like, if constraints are there. Oh, constraint is there or not? Okay, only that constraint is there. Fine. So Okay, this one is later. Okay. Okay, I should not write that. Control X. Okay, so this is the first problem that we have. 10 x2 minus x1 square total whole square plus 1 minus x1 whole square. So we'll just run this. I hope I have explained this. It's mostly clear. Control enter. See, the best memory is how much? 1 comma 1, and the best value is 0. Okay. I think lower bound upper bound whatever I have given is correct only. We'll see the answer. So the correct answer with starting point as 0 0 should be 1 1. What was that? Okay, even if you don't in that you have to put fine. So how much we are getting? The best member x1 x2 we are getting as 1 comma 1. Okay, so the correct answer will be
1 comma 1.
1 comma 1, the B. Okay. Okay, we'll move to the next question. This one is done. Okay, next question is again use differential evolution, minimize this function, but there are few constants to it, right? So the constant is 2x1 plus x2 is less than equals to 2, and this constraint, that is x1 x2, lower bound is minus 5 and upper bound is 5, right? We just need to solve this. I have written the code again. So anyway, I have explained the whole de-optimization with constraints also, so we'll just run that. So this function, you can see we have only one constraint, right? Because minus 5 to 5 is the lower and upper bound, so we can directly give that in the de-optim, right? So we can just give it here, and I have not written the summary. Just to see the summary, I'll write it here. Okay, so this is the function, objective function, x1 minus 3 whole square plus x2 minus 3 whole square, and the first constraint was what? See here, it is 2x1 plus x2 is less than equals to 2. So just to write in the same format, that is less than equals to 0, we'll write it as 2x1 plus x2 minus 2. Okay, so here 2x1 plus x2 minus 2, and again we are giving some offset if it is not valid, that is this. Or else what you can do here also, if you write, okay, first we'll do this and then we'll see if that works or not. Control enter. So how much we are getting? Best member we are getting as 0.2 and 1.6, and the best value we are getting as 9.8. okay, just remember this, and we'll see if without less than equals to 0 if I write. So I hope this you got. So not just writing minus 2 here and writing g1 or the constraint as minus, like less than equals to 2. We'll see if the same answer we are getting or not. Control enter. See, we are getting the same answer only. So you can write like that also. Okay. Okay. So correct answer will be best memory is 0.2, 1.6, and best value is 9.8. Just check what was the question. You just have to say the function value. So the correct value will be 9.8. So B will be the answer. Okay. Okay. Differential equation is differential evolution is clear, right? The functions and all.
Yes, sir. Yes, sir.
Okay. So we'll move to the genetic algorithm, but with some constraints again. Yeah. So this one you are asking, right? X to the power 13. So yeah. So we have written that also here. Okay. So again, this also we have to do. You can do it in R. You can do it in MATLAB, wherever you want, because you have learned everything now. I'll see. I think I have written it in maybe in MATLAB only, I think. Just check. I think this. Let me see. Multi. Not this. What was the function? X. Okay, same function. Fine. MATLAB. Yeah, this one only, I think. Yes. Okay. So we'll just first see once. Okay. So I'll just clear everything first. F9. So the objective function is again x1 squared. This objective function you must have seen by now so many times. Now the lower bound is minus 3 comma minus 3, and because two variables are there, and upper bound is 3 comma 3. Okay, you can write this in that form also, remember, once like 3 into like this you can write 3 into ones of first sorry one row and two column. Okay, like this also you can write. Okay, so whatever is fine for you, you can write in that fashion. Okay, this is your code. Just remember that code should be efficient. Okay, the time for the computer should be less, so write functions like that. Okay, so lower bound and upper bound is this. A, we are keeping A B C D, we'll just see what is that. So A EQ means equality constraint I'm writing. Okay, B EQ as in second constraint but with equality constraint. Okay, so like that A and B is there, and this NON LCON means non-linear constraints. Okay, non-linear constraints, so we are just putting some blank non-linear constraint, and int constraint as in integer value constraint. Okay, so again if you just see the GA function in the documentation section of the MATLAB, you can find this one. So again x is the x value, or maybe if x1 x2 are there, the values of x1 x2 at which the optimized function value you will get. This fval is the optimized function value. Again this obj function, whatever you have written here you should write here. 2 is the number of variables x1 x2, this a and b will see. Okay, okay. Now coming to the constraint multivariable, same thing whatever we have seen here is I have written it here. Okay, there, here I have not put any constraints, only objective function is there, right? That's why I have put all this as blank. Okay, if all this is blank, this means these does not exist, a b a q a b q and all whatever. But now coming to the constraint optimization, same objective function. So here I am just writing the function as objective. Okay, a lower bound upper bound you can write in whatever manner you want. Okay, now what we are doing, okay, here also I have not written. So here you can, in this function you can write the linear inequality constraint and all that I will see. What was the question? No, this one was not the question. Why did I write that? What happened? Okay. Not this. Not this. Where did I write that? This is multiple objective optimization. Did I write that or not? Okay, okay, it was there. I was showing somewhere. Okay, I wrote this for particle swarm optimization. Fine. I think yes. Yeah, I wrote it for particle swarm optimization. I should have written. So same thing you can use this GA MATLAB, but here you just need to call that function. I'll do that once. So what was that function? Not this one, right?
x1 square plus x2 minus 11 square.
This one, this one. Okay, so O1 is the function. Fine. Okay, I'll just write it here. So lower bound and upper bound, I hope, what is there? Lower bound, upper bound is 0 and 5. Fine. Lower bound is 0, upper bound is 5. Okay, non-linear assignment we have to do. Okay, or else I'll explain it with some other, otherwise the writing will take 4-5 minutes. First I'll explain this multi-objective optimization and all, and then we'll come to that. Okay, So in multiple objective genetic algorithm, anyway we have now we know that what is multiple objective optimization and all. So there will be more than one optimization objective function. So let's say for example, in any field you want to irrigate, so for that you need to have one, let's say if you have one objective function for how much area is there, then one objective function for how much water to be allocated and so on. So there can be different objective function, and then there can be different constraints also. So that comes under multiple objective optimization problem. Okay, now we'll see the function again. The function can be non-linear, the constraints also can be non-linear and so on. So here lower bound, let's say we are putting as 0 0, upper bound as 1 1. Objective function we are writing as this function multiple GA. So where is that? Yeah, here. So the function is this. Okay, the function is f1 is the first objective function and f2 is the second objective function. So this is only for the multiple objective function. Okay, so the first objective function is simply x1 and the second objective function is 1 plus x2 into e to the power minus x1 divided by 1 plus x2. Okay, and now we are keeping these two functions in this, that is objf as. So now this function again will become a vector of two functions, that is f1 and f2, which is written in this fashion. Okay, we'll go to that again now. So I hope this is clear now. Obj function now you know. Now nonlinear constraints, so again we have to create functions for constraints also. Okay, so nonlinear constraints will be there, so that we are keeping in this nlcon as in nonlinear constraints multiple GA. So here you can see what I have done. I have put two constraints, that is C and CEQ. This CEQ as in, this CEQ means equality constraint. So in this problem, let's say we don't have any equality constraint, so we have put empty vector. Okay, so there is no function in this, but this again C is again vector. In this we can put several functions that we want. Okay, and the name you can give whatever you want. Okay, so function is f1 and f2. C1 and C2 are the constraints. First constraint is minus 1 into again C. Remember this constraints, again this constraint is having functions, so there can be possibility that the constraints that you are having is a function of the objective function itself. It is also possible. Okay, so here it's not like only variables can be there in the decision variables are there in the constraint, but the functions can also be there. So the function is, the constraint function is minus 1 or minus f2 by 0.858 e to the power minus 0.541 f1 plus 1. Like that you have the second constraint also. So these two are the constraints. So that's why we have written f1 and f2 again, because we need that f1 f2 in the constraint. If the constraints only contains the decision variable, you don't have to write this f1 and f2 again. Okay, okay, right. Now linear constraints, so whatever linear constraints we'll put it a and b and also on. Now you can give several options, so these options you can go to the documentation and see. I'm not going in detail. Okay, anyway sir has explained all this, I'm not going. Now result and eval, so you will be using this GA, then multi as in multiple objective, so that's why GA multi obj. Okay, so obj function, 2 is the number of variables a and b and all these things. Then if you just want to plot the scatter plot, you can do that. Okay, and I have written it again here, it's fine, no issue. Even if you don't write it here, it's fine. Now it's not working only. Okay, so I need to run the whole thing, so I'll just run maybe. Get the scatter plot.
Sir,
Yes, yes.
just a general question.
Hmm.
Actually, I have registered and
Sorry,
enrolled for
your
two
voice
courses.
voice is breaking. Can you say again?
I have registered for, yes, sir. I have
Hmm.
registered for two courses.
Hmm.
The courses are exams are on Saturday and Sunday, 26 and 27.
Okay.
Choice, preference in city, everything I have given in the beginning itself.
Okay.
Now my problem is, will they allocate two cities, two different cities? Are they mapped properly?
Uh, that might be possible, but mostly they will try to give in the one city only.
Because next day itself, so I
Yeah,
can't
yeah,
travel also.
yeah. If that is the case,
And the Diwali time festival.
mostly they will
This
give.
course only 165 students enrolled for
Yeah, yeah,
exam.
yeah. I
The
have seen that.
other course also other course someone. But no problem any city. But that city also is the first preference I have given nearer to my house only. Second
Mm-hmm.
preference everything.
Yeah, you will
Will
get
they
in the
give from my
near only.
preference only, sir?
Yeah, yeah, yeah. They will first give from your preference only if that city is there in the
Okay.
list. Yes.
Okay.
Don't worry about that.
I mailed them, but I didn't. I
Get it.
called them also. They didn't pick up.
No, it's fine. They will give. Don't worry.
Okay, sir.
I don't know why it's not working. Function obj function. Okay, fine. Wait. I'll delete this. Because the average change in spread operator is less than the options. Okay, so there is some issue here. Mm, okay, if I run only this, it is getting stopped because the average change in the spread of Pareto solutions is less than the options. Okay, if we don't give the plot function, let me see if it works or not. Mhm. So this we have to change this Pareto distribution, and we have to just see at what generations and all it can work. So it's not like for every functions your particle sum optimization will give proper result or it will work. Okay, so based on what from where you because all these functions whatever you have seen till now are like given right to you, x1 plus x2 plus x3 square, something like that. Most of the cases in application, what we do, we have some problem in our hand. For example, what I said, that for irrigating one field you need to know the area, you need to have water allocation and so on. So all this optimization problem comes from some of the application. So in that, if you know the application, if you keep working on maybe other evolutionary algorithm, you might be knowing that okay, for this it will work. So sometimes you have to uh, shuffle what generation it is working or not, whether that method is suitable for the application that you are doing or not. So based on that, that might happen. Okay, this I think in the week lectures also sir has informed. So maybe we'll go to that question once. Okay, or else you can write this. I have not written this, I have written for particle swarm. Okay, so if you see the particle swarm only, if I run, then you can get the answer. Genetic algorithm also you can write just like that. Okay, particle swarm, where it is that? Yeah, it is here. Open, where is open? Open. I've used open anywhere. Yeah, okay, I'll do it here. Control C. What are the lower and upper values? 0 and 5, fine. 0 and 5, 0 and 5 correct only. Fitness function, O1, O1 is there. Yeah, it's there, okay. And then fitness function, this one, 2 LB, UB, okay, correct. Let me just run this. Okay, so using particles form optimization I did this. Okay, you can write GA code for this also. Okay, so for this how much we are getting, sorry, yeah, thing is happening. Okay, so we are getting values as 3.17, 1.27. This can again vary if it has different local optimum, but the function value you are getting as 5.002 something. Okay, so with genetic algorithm I also hope it will get near this. Okay, it might be 4.999 and something like that. So the correct answer will be 5. Okay, I hope it is clear. Next question will move. Okay, next question is minimize this function. You can use any MATLAB or R. Okay, I'll just maybe this also I did in MATLAB only. The thing is, which problem I did where I don't remember. OB fun, let me check. No, OB fun we have did, right? No, it's not this. What was the function? 3x1 square minus 2x2. Okay, 3x1, not this one. It's a function. x1, x2, not this one. Now the question is in which I have written. Oh no, I have written for GA also. Okay, fine. It should work here. It's there. This one. Okay. I have written so this. Let me check. This is the function. 3x1 square minus 2x2, 19.4 and 4. Okay. Okay. So this is the function for the current question that is there. So these are the constraints. You can write this in another also. N call assignment I would have written. Yes, it is there. So this is for the constraints. Just now I have explained that how in GA you can write all those. Right. Now we'll just run this. I think this is 3x1 square minus 2x2. Yes. A lower bound is given minus 5 to 5. Correct. And call assignment. Okay. We'll just need to run this. F9. Okay, I did some mistake. What is that? You mean no, no. X is there or not? No, wait. Objective is this correct? What is the problem? In this, it is saying unrecognized functional variable intcon. Okay, where is intcon? This one. Intcon. I have not explained anywhere. What is intcon? Oh, integer variable, integer constraints. So I have not, in this there is no integer constraint. I'll just remove this and I'll again run this. F9. Yeah, now we got. Okay, so the x value is minus 0.2 and 4.4 and the function value is minus 8.68. You can just check it here also. See, the function value is minus 8.6801 and where is x? Yes, here is minus 0.2 and 4.4. Okay, so we'll just go to this. So our answer is, what was the answer? Minus 8.68, right?
No, option D, minus
minus
8.6.
8.68, correct. Okay, next question will go. So minimize f of x1 x2. Again same question only, I guess, right? Yeah, same question only, but use Excel solver.
But Excel solver.
Okay,
Yes.
I'll show this one also then. Some other sheet I'll do. Mm,
Excel solver is easy, not
yeah,
it's
Excel solver is
MATLAB
easy.
requires more coding, MATLAB and all.
Coding is
But
more,
we
but
can't
the thing
solve
is, here in Excel you can do simple problems. Okay,
simple.
if
Yes.
it is big functions in mostly application, if you see, uh, sir has explained about design problem, I think, beam design
Yes, sir.
problem,
Yes, sir. Yes,
and
sir.
one
Welded
groundwater
still.
problem also side. So those kind of function you will find while working. A simple
Yes.
problem you will not find. So yeah, Excel is easy, that we can understand. But variable variable are x1 x2. I'll write x1 x2, and then maybe objective function, let's say f, and constraints. Okay, how many constraints we have? Two, three constraints. Okay, we need to put the lower and upper bound also. No, that I'll write later. Fine. mm, Constraints are, maybe I'll write g1 equals, first I'll write some initial value I'll give here, or
Initial values should be zero. Zero, zero.
you can give any initial values, it's not a big thing. Fine. Equals, okay, see here, this is one of the equality constraint. Okay, and then this is less than equal to type. So just whenever you are doing in MATLAB or R, just be cautious with that. It should be, sorry, 2 into x1. This is the same problem, I think, which sir has done in lecture. Okay, x2 minus 4. Okay, then g2 is what? X1 square equals x1 square plus x2 square minus 19.4. Fine. This also you can write as g3, sorry, g3 maybe. Either you can write as like this g3 constant, or you can write as lower and upper bound, whatever you want. Okay, so this should be, x1 should be less than 5, so x1 minus 5 you can write, x1, sorry, equal to x1 minus 5, right, g4. By this way it will be so many constants, that is better, I think. x2 minus 5 minus 5. Okay, first let me do that function को right लिखते हैं, equals 3x square, 3 into x1 square minus 2 into x2. Okay, okay, but before that, one more thing I have missed. I think I have explained that also once. Wait. Yeah, in the last problem, remember, here we were doing the objective function, right? So here we saw that there are three problems, right? If you go to solver option, here you see other than simplex and GRG non-linear, you have evolutionary algorithm also. This also you can use. But see, what you're getting all variables must have both upper bound and lower bounds. So if you want to solve using evolutionary algorithm, you have to mention the upper bounds and lower bounds. Remember, in all the evolutionary algorithm that you have seen, genetic algorithm or particle swarm optimization, in both the methods you have uh, given the lower bound and upper bound. Okay, so for these kind of evolutionary algorithm, you need the upper bound and lower bound values. Okay, just to inform. And it's 7:52, I think. Mm, this Excel, this question, no, this is simply the whatever is there in the class. So I'm not again doing that. Okay,
Okay,
this
sir.
so you'll get the minus point 2 and 4.4 similar. Okay, other
Same
than
like MATLAB.
same like my
MATLAB also we got
value,
the same.
yeah, values you'll get similar. It might be like
Okay.
0.1999 something, 4.40 something,
Yes.
but all the methods should be converged at the same point. Yeah, some methods for some functions it might be difficult, so based on the application we have to think that which methods to apply and so on. Okay, so with this
Okay.
I'll stop. Wait, कहाँ गया? With this I'll stop. If you guys have any questions later, you can post in the discussion forum. Whenever I will see that, I'll answer. Okay, and
Okay.
all the best for the exam.
Thank you, sir.
Okay,
Thank you for your learning, teaching.
thank you so much.
It's
Yeah,
you are very sincere. But I couldn't attend some classes because I had the clash. That's what I mentioned in the
yeah, yeah,
discussion
AI
forum.
wala. Okay, fine.
Yeah, yes.
Hmm. Yeah, it's fine.
Anyhow, I watched the videos now on the next day.
Okay,
Thank you, sir. Thank you
okay,
for your support.
okay. Thank you so much. All the
Thank you.
best. Yeah, bye bye.